G'day guys. Today I'm going to do an introduction to Chapter 6 in the Year 11 Advanced Cambridge textbook. Chapter 6 is basically a rehashing or a review or a revision, if you like, of concepts that you would have already seen in the stages 4 and 5 courses in coordinate geometry. So imagine I've got a number plane, the XY plane. Okay, if I pick two random points on the plane, and I wanted to know, well, first of all, let me label the points. Okay, now mathematicians, let's face it, they're not exactly the most creative bunch of people in the whole world, right? So when they name things, they tend to come up with lame or redundant or overly complicated names of things, right? And sometimes they manage to roll all of that into one thing. So let's look at this guy. So every point on the number plane is defined in terms of its x and y coordinate. Okay. So this guy here has got an x coordinate. So I'm going to call that x subscript 1. Now it's not a power, it's not, so let me explain this just for complete clarity. I write x subscript 1. So in the same way that if I was to write a power, the power would be up here. Well, this is the same idea, except instead of a superscript, it's written down as a subscript. It's not a power, it doesn't mean that anything in particular is happening to x. I just use that subscript to differentiate between this x value and the x value for over here. So I call this guy's x coordinate x1. I'm going to call this guy's x coordinate x2. It doesn't mean that that's 1 unit and that's 2 units. It just means that this is a particular x value and this is a different x value, and I've got different names for them, that's all. Likewise, this guy here, he's got a y coordinate as well. I'm going to call him y1. And same deal, this guy is up here at y2. So if I think about the triangle that those 2 points form the hypotenuse of, well, that triangle is a right-angled triangle. Okay. Now, when we think right-angled triangles, we should remember our old mate Pythagoras and Pythagoras' theorem. What did Pythagoras' theorem tell us? Pythagoras' theorem told us that the square on the two short sides, the sum of the squares on the two short sides was equal to the square on the hypotenuse. In other words, this length here squared plus this length here squared was equal to this length here squared. Well, what is this length here? Have a look at this. This distance here is exactly the same as this distance here between y1 and y2. Well, what's the distance between two different numbers? If I was to ask you your age, so if I was to look, how old are you? And through the magic of YouTube, I listen and I hear you yell back, Mr. Obeid, I'm 16. I think, okay, that's great that you're 16. I happen to be 21. Okay, so if you're 16 and I'm 21, what's the gap in our ages? Well, it's 5 years. Now, how did you do that? Did you go 16, 17, 18 and count it out on your fingers or fingers and toes? Or did you go, well, between 16 and 21 is 6 years? I know that because 21 take away, it's 5 years, so forgive me. So between 16 and 21 is 5 years. And you did that by subtracting the higher number from the lower number. Okay. Well, the way you get that between 21 and 16 is 5 is of course through subtraction. So the distance between this number and this number we find by subtraction. This distance over here, the length, the vertical part of my triangle is equal to y2 minus y1. Same deal across here. The difference between x2 and x1 is x2 minus x1. Exactly in the same way as the gap in here was y2 minus y1. The gap here is x2 minus x1. Well, let's apply Pythagoras' theorem to this. So if I call this distance here d, well, Pythagoras' theorem tells me that d is equal to the square root of that distance squared plus that distance squared. And that's the distance formula. So anytime I know the coordinates of two different points, I stick those numbers in to my distance formula and I just crank away. I just turn the handle and the formula takes care of the rest for me. The formula is not some magic hard thing that mathematicians have made up to look complicated. It's the ideas are very basic. It's Pythagoras' theorem and differences between two numbers. And it's just applied in this particular context here. I'm going to talk about one more formula and then I'm going to look at examples of both formulas. So I've got the distance between these 2 points. Another thing I'd like to find is the midpoint of those 2 points. So the point that is exactly in the middle. So that there is equal to that there. Okay. Well, if you think about the middle of these two values, well, the middle there will end up being the exact middle of these x values. The exact middle of these x values. Well, how would I find the middle of two numbers? Let's go back to our ages. I'm 21 and you're 16. How do I find the exact middle? Well, if you're thinking the easiest way to get the middle of two numbers is to get their average, you're completely correct. So the exact middle of x1 and x2 is going to be x1 plus x2 divided by 2. Likewise, the exact middle of y1 and y2 is going to be the average, y1 plus y2 divided by 2. So there's a formula for the x coordinate at my midpoint, and there's a formula for the y coordinate. I can put them together and say that my midpoint is equal to x1 plus x2 on 2 as my x value, and y1 plus y2 on 2 as my y value. Okay, so I'm going to clean this off the board now. We're just going to use those two formulas there, and we're going to look at examples of finding the distance between 2 points and their midpoints. Stay tuned. So if I'm asked to find the distance and the midpoint between A, which is -3, 4, and B, which is 5, 11. Okay, they're just random coordinates that I made up. So if I'm asked to find the distance and the midpoint between both of those, what I start off doing is I start off by labelling the coordinates. So I'm going to call one of them is going to be my first point, one of them is going to be my second point. It doesn't matter. It doesn't matter which one I call my first or my second, so long as when I say this is my first, I'll make that my first x and my first y, and this is my second, that's my second x, that's my second y. I could just as easily say that's my first x, first y, second x, second y. It doesn't matter what order I pick these in. Okay. So the first thing I do is I label the coordinates of these points. So I call that x1, y1. And I call this guy x2, y2. And I was asked to find the distance, so I'm going to write down the distance formula. The distance formula, remember, was the square root of y2 minus y1 squared plus x2 minus x1 squared. And now it's just a matter of me very carefully substituting. So that's the square root of 11 minus 4, y2 minus y1, 11 minus 4 squared, plus 5 minus negative 3 squared. Okay, what's 11 take away 4? That's 7 squared plus 8 squared so I get the square root of 113. If a question asks me for decimal places, it probably won't, but if a question asks me for decimal places, I can then go and put that into my calculator. If there was a square number that went into this surd, I'd certainly simplify my surd, because remember, every time you see surds, what's chanting in the back of your heads, guys? Square numbers, square numbers, square numbers. We're looking for square numbers. There's no square numbers that go into 113. So that's it, we're job done. Okay, there's no more we can do there. There's the distance between A and B. Well, what about the midpoint? Well, recall that midpoint was equal to x1 plus x2 on 2, y1 plus y2 on 2. So I'm just going to substitute those values in. x1 plus x2, negative 3 plus 5 on 2, 4 plus 11 on 2. So over here I've got 2 on 2 and 15 on 2. So I've got 1 and 7.5. Or 15 on 2 if you prefer the improper fraction. Okay guys, that's distance and midpoint. We saw where the formulas came from, we saw what the formulas were. Just before chapter 6a starts, there's some little reminders for you, I guess, of some different qualities of different quadrilaterals. It's a good idea to be familiar with those, because you might get a question that asks you about points and whether or not they form different types of quadrilaterals. So you need to be able to work out distances and then know what they mean. I'll leave you to read that little table of definitions, if you like, of different properties of quadrilaterals before chapter 6a, and then to make a start on 6a. Most of the work on 6a is not drilling you on all this sort of quadrilateral work, so don't worry, don't feel burdened by it. Most of it is just making sure that these two techniques that you see here, you've got 110% well and truly down pat. Remember what I said in our chat, that this pre-calculus work is pivotal to your work on calculus. Okay, this is the stepping off point before we start looking at differentiation and integration, which is the meat and potatoes of calculus. Make a start on exercise 6a. Let me know if you've got any problems. Comments below or over on our Microsoft Teams page. Either way, guys, I need feedback from you to know how it's going. I'm here to help. Let me know how I can do that. Thanks, guys.